Australopithecus Robustus, a look at adaptive radiation and specialization. The student is John McKay. The citation format used is MLA, and the presentation was created using Microsoft PowerPoint. Now, a disclaimer. I am but a student and a young one at that. I have consulted with experts and did copious amounts of research and studying, but I am not infallible. If I accidentally stated something that is factually incorrect, please let me know. Also, before we begin, I would like to extend a personal thank you to the wonderful Professor Johanson for his incredible instruction and patience. Without him, this presentation would not have been possible. Meeting him and taking his ASU course on paleoanthropology have been wonderful experiences, and he is genuinely one of the most inspiring people I've ever had the pleasure of speaking with. That is all. Now, the purpose of this presentation can, I feel, be summed up by 3 points. First, to explain why Australopithecus robustus is a perfect example of how evolution, specifically within the context of specialization and adaptive radiation, functions. Second, to clear up some misconceptions about evolution, its functions, and how it relates to early human ancestors and relatives. Third, to introduce those watching to something new, something they were potentially unaware of. Now, before we dive into the heart of the presentation, I will first define a few terms in order to ensure that we are all on the same page, as well as make things clear as possible for those who are less familiar to the field of paleoanthropology. First definition is theory, a supposition or a system of ideas intended to explain something, especially one based on general principles independent of the thing to be explained. Contrary to the everyday use of the term, a scientific theory is not a suggestion or a possibility or an idea. It is a model with substantial evidence to back it up that is used to explain how things work. Theories are not set in stone. They are fluid, ever adapting to new information that comes to light. The theory of evolution, for instance, is an explanation for how the species we see today have come to be. The theory of the Big Bang is an explanation for how the universe came to its present state. Germ theory is an explanation for how we get sick, etc., etc. Despite the adaptive nature of theories, this does not make them laughable or something that can easily be brushed aside. Theories are our best explanations for how things work, and again, we have numerous amounts of evidence to back them up. Evolution, the process by which different kinds of living organisms are thought to have developed and diversified from earlier forms during the history of the Earth. The theory of evolution is the best model we have to explain how the diversity of species we see today exist. We have countless pieces of evidence to back it up, and new information is constantly coming to light, allowing us to understand how it works even further. Evolution is based on a principle known as survival of the fittest, or as Dr. Johanson would say, elimination of the unfit. One thing to understand, following this, is that evolution is not the progression of an inferior species to a superior one. Evolution happens because sexual reproduction causes slight changes to DNA structure with each new generation. These slight changes can either be beneficial, in which case the individual is more likely to pass on its genes, allowing the change to remain and carry on, or it's not beneficial, in which case the individual dies or somehow cannot pass on its genes. Essentially, all that matters in terms of evolution is whether or not the individual can survive long enough to reproduce. Adaptive radiation, the diversification of a group of organisms into forms filling different ecological niches. As stated in the previous slide, evolution is the exaggeration of traits throughout the generations. As a species grows in size, some of the population may break off and settle a new space, which may be a different environment from the original, causing those individuals who have the traits needed to thrive will be the ones to pass on their genes, and so these new individuals will fill the ecological niche and have a slightly or totally different kinds of traits as a result. Specialization, the adaptation of an organism or part to serve a special function or to suit a particular way of life. Specialization is somewhat similar to adaptive radiation in that traits exist because the individual was able to live long enough to pass on these traits, and that generally corresponds to being better suited to the environment. Now, again, as time goes on, those traits will become exaggerated and fit to the environment, hence the term survival of the fittest, or elimination of the unfit. In short, specialization is essentially a species' adaptation to its environment. Sagittal crest. In many mammals, a bony ridge on the top of the skull to which the jaw muscles are attached. We will talk about why this exists at a later point, but needless to say, it's important. Zygomatic arch. The bony arch of the cheek formed by the connection of the zygomatic and temporal bones. a zygomatic arch is the cheekbone. This is also extremely important, and we will discuss this later. Now, one of the first things we must ask ourselves when considering Australopithecus robustus is, what is the genus Australopithecus? Why is it special? Australopithecus is of the order Primate and the family Hominidae, same as we are. In fact, we are descended from a certain species of this genus, but that's a discussion of another time. The name Australopithecus means southern ape, Australo meaning south, and Pithecus meaning ape. What's special about this species is the fact that we have so much information about them, more than we do of species of our own genus, Homo. We know they existed for a considerable amount of time. We know that they were bipeds, which is extraordinary considering the time span they existed in, and we know that they, at least compared to us, had much smaller cranial capacity, meaning their brains were smaller than ours. The above are just some of the many species of Australopithecus. One thing that we need to remember is that there are essentially two different types of Australopithecus, gracile and robust. Gracile species are ones like Africanus, Afarensis, and Setiba, and we're most likely descended from one of the gracile species. However, the ones that we're going to talk about today are Robustus and Boise, another robust species. Now, a question that one might ask is, what is the difference between a gracile and robust Australopithecus species? And this is where the definitions I gave earlier come into play. In the next section, we're going to look at some robust species, compare them to their gracile counterparts. And then we're going to talk about why they're so distinct. The first species we'll talk about is Australopithecus robustus. The image here is an incredibly preserved robustus skull, and I'll be using it for reference. Now, Australopithecus robustus has many defining traits, but some of the most noticeable are large, bulbous teeth, as you can see here, massive jaws, flared zygomatic arches, or cheekbones, and small cranial capacity. Like you can see from the image alone, it has a very small head. And then, of course, it also has a sagittal crest, and this is this little spike here. Now, a few other interesting things about this species is that it was bipedal, which is very interesting. And despite the fact that it has many ape-like characteristics, its primary form of locomotion was walking on two legs. Another interesting thing about this species is that it existed from around 2.7 to 1 million years ago. So that's pretty cool. Now, we move on to the other robust species we'll talk about, Australopithecus boise. We'll take a look at the skull and mandible of this species in a later slide because they really are quite special. Boise is quite like Australopithecus robustus in many ways, but one of the things that differentiate is that it is one of the most robust out of all the robust species, to the point that it's been termed hyper-robust. Like Robustus, it had a sagittal crest, although many of the female specimens have less defined sagittal crests, oddly enough, and flared zygomatic arches, as well as very large teeth. Now, an interesting thing to note about its cranial capacity, or brain size, is the fact that it's around a fourth of the human brain. Humans have heads that are disproportionately large in comparison to their bodies, so it's amazing. It's an amazing example of evolution. Oh, and of course it was also bipedal. Now, let's really dive into the differences between gracile and robust Australopithecus. I'm just going to increase the thickness of my marker. Okay. Now, here we have two wonderful fossils, one being the skull of Australopithecus afarensis, a gracile, and the other being Australopithecus boise, as I talked about earlier. Hang on a second. Okay. Now, and immediately there are two things that differentiate them, the zygomatic arches and the sagittal crest. See, here on afarensis, we see that the zygomatic arches are indeed flared, but they're rather short. But bosi has long, tall, broad, thick arches, as we can see here. Then we can see that afarensis has a fairly rounded, smooth skull, but Boise has a huge sagittal crest on it. You can also see that the brow ridges of Boise are significantly more defined than in Australopithecus afarensis. See, it's pretty shallow. And then, of course, afarensis has much larger eyes, and its face is less prognographic, or it sticks out less. Here's another point of comparison between the two species. And between gracile and robust Australopithecus, their mandibles and teeth. On the left, we again have Australopithecus afarensis, and on the right, we have Australopithecus boise again. We can see that the jaw of afarensis is relatively thin and shallow. Its palate is rather shallow in comparison to Boise. You can see here that Boise's jaw is absolutely massive and is, in fact, around 2.5 inches thick. We can also see that the teeth of Boise are much, much larger than that of afarensis. Now, we finally get to the reason for this presentation's existence. Why do the robust species have the traits they do? Why do the robust Australopithecus have sagittal crests, flared zygomatic arches, massive teeth, and limited cranial capacity? The answer is diet. The robust Australopithecus had an incredibly fibrous, rough vegetarian diet of roots and tubers, so the sagittal crest and flared zygomatic arches are to accommodate the temporalis and masseter muscles, whose primary purposes are chewing. The reasons why their brains were so small is because brains are quite actually energy hungry, and the diet they had couldn't allow for the extra calorie usage. Their teeth were so large because they needed to be able to grind up the food they had. The sorts of foods that the gracile Australopithecus had to eat were much softer and easier on the jaw, so they didn't need to adapt in the same way, which is why you see larger brains and larger overall bodies. The robust Australopithecus found itself in a rough environment where the only food available was tough, so the individuals who had these traits, as I've described earlier, were able to live and pass on their genes. So the robust species of Australopithecus really do show what evolution can do in the face of a struggle. Thank you so much for watching. Apologies if I stutter. I am working on it, but it still comes through sometimes. Here are the sources that I've used. I'll wait a couple seconds on each of the slides, so you can pause and take a look at them. Okay, here's page 2. Alright, bye!